This is Algebra 2 with trig, 8A.1. This is kind of a refocus back on right triangle trigonometry. So from geometry class, what we've talked about before is a term called SOHCAHTOA. And SOHCAHTOA helps you remember what the trig ratios are. You can use trigonometry whenever you're working with a right triangle. So given a particular angle, we'll call that theta. Sine is considered the O and the H, the opposite and hypotenuse. So sine of theta is a ratio where we take the opposite side divided by the hypotenuse. The cosine, looking at SOHCAHTOA, C stands for cosine, A stands for adjacent, so that'll be the side next to the angle, and the hypotenuse. And then tangent of theta, which means of the angle you might be talking about, will deal with the opposite and the adjacent. So notice that the O and the A are a little bit different each time. This says O and H, A and H, and O and A. So every time the ratio is a bit different. Opposite and hypotenuse is for sine, adjacent hypotenuse is for cosine, and tangent is opposite over adjacent. Notice that when we talk about sin, we're not pronouncing it sin. We always pronounce it sine. Just like with cos, we don't pronounce it cos or tan. We pronounce it cosine or tangent. Another calculation you can do with every right triangle is the Pythagorean theorem. Pythagorean theorem focuses on the hypotenuse squared and the sum of the square of the legs. Hypotenuse squared equals leg squared plus leg squared. So you have different options depending on the situation you're dealing with. You can use your knowledge of right triangle trigonometry and inverses to find angle values of a right triangle. So here we're trying to calculate theta. This symbol right there is theta. It's a Greek letter. It's kind of like a circle with a line through it, or it's kind of more like a curved line. Stands for theta. It'll represent an angle in mathematics. And it's in all the advanced formulas as you keep moving further in math. So for us to calculate theta, we have to identify which side is the opposite side, which side is the adjacent side, and which side is the hypotenuse. So the opposite side is always going to be across from the angle that you're working with. So I often call it an angle of perspective. In this case, it's theta. So across from theta is the opposite side. Across from the 90 is always the hypotenuse. And the other side is always the adjacent. It's always going to be the other leg, the leg that makes the angle. The leg next to the angle is considered the adjacent leg. So now we notice that we have a 4 and a 9. We're trying to calculate an angle. We have the adjacent, we have the hypotenuse. We think about SOHCAHTOA. we notice that adjacent and hypotenuse, the AH, goes with cosine. So I'm going to say cosine of the angle, which we'll label it as theta, because we don't have an angle value to put there. Cosine of theta is going to equal the adjacent side, which is 4, divided by the hypotenuse, which is 9. Now, if we don't know what theta is, but we have two sides of our right triangle, we can calculate what theta is. We're going to switch the theta and our ratio. To switch those, we need to use what's called the inverse trig function. So that's cosine inverse is going to give us our theta. Now, for us to use a calculator, all right, we often use a calculator to help us determine these values because we get so many decimals. A good way to see if you're in the correct mode is if you say sine of 30 and get 0.5. Well, I don't have 0.5. That means I'm in the wrong mode. So you need to take your calculator, go to mode, and you'll get a menu. You need to come down to degree and highlight degree, because when we talk about angle values, angle measurements, we're doing those in degree. Later we'll talk about radian, but now we're talking about degree. We're familiar with 90 degrees, 180 degrees, 30 degrees. So we're going to talk about this in degrees. Now, to get out of this menu, in any menu, you often can hit quit. So that's in blue letters. So second mode takes you out of that. And if you type it again, sine of 30, and now we get 0.5. That means we are calculating with a degree value, and we already know using special right triangles that the sine of 30 is 0.5. This must have been implying that it was a radian measure, so it wasn't calculated right, wrong units, and it gave us the wrong answer. So we're going to come down here and do the cosine of 4 over 9, cosine inverse. So second cosine button gives us cosine inverse of 4 divided by 9. If your calculator doesn't automatically put a parenthesis there, because it's a fraction, you need the parenthesis there. You can close it if you wish, and you'll get your angle value, 63.61. So if you know the sides of any right triangle, you can calculate the angle value by using the inverse trig function. Figure out any angle you need to. Let's come over here to our next triangle. Here's theta, so the opposite side is going to be across from it, abbreviated OPP, opposite. Adjacent is going to be next to it, and of course the hypotenuse is across from the 90, but we don't need that for this case because we don't have any number there. We need the two sides that have numbers. So theta, opposite over adjacent, we're going to be working with tangent. The opposite side divided by the adjacent side. SOHCAHTOA reminds us that tangent is the opposite over adjacent. I'm solving for theta. I need theta by itself. So I'm going to switch those two. In doing so, I'm going to use tangent inverse. And I put theta on the other side of the equal sign and 10 over 8 over here with tangent inverse. go to my calculator. Second tangent will give me the inverse. 10 divided by 8 will give me my 51.34 degrees. And that's theta. So for this one, you notice where theta is located. So across from it is considered your opposite side. Across from the 90 is considered the hypotenuse. And then the side that we're not too interested in at this point is next to the theta. That would be your adjacent. But we don't have any numbers there. We're not too interested in adjacent. So you could look up here. Cosine requires adjacent. Tangent requires adjacent. I'm not going to use either one of those. I must be using sine. Sine has the opposite over the hypotenuse, the 5 and the 12. Sine of theta equals 5 over 12. I'm going to switch those to get sine inverse of 5 over 12 equals theta. And I can type that into my calculator. Second sine gives me sine inverse of 5 divided by 12. And that gives me 24/62. All right, this next question. What is the measure of the angle in our triangle? So, pause the video, work through this problem, turn it back on, see how you did. So we're going to look at this theta and go across, and that's opposite. This is adjacent. So SOHCAHTOA tells us that that's going to be tangent. Tangent of theta equals the opposite over adjacent. Now, if we're solving for an angle, we're going to switch the ratio with theta. So to do that, that requires us to use tangent inverse. Now we have theta by itself. And we go to our calculator. We need to be sure we're in degree mode. Sine of 30 confirms that we're in degree mode if you get 0.5. So tangent inverse of 17 divided by 6 gives us 70.56. Those are degrees. That's our value for theta. Any triangle, any right triangle with a ratio of 7 divided by 6. It could be 34 over 12. It could be half of this. So what, 8.5 over 3. Anything that reduces, just like 17 over 6 does, is going to require the angle of 70.56 degrees. The sides can't be any different than that ratio. All right, our next part is solving a right triangle. To solve a right triangle is to calculate for the missing sides and angles. Typically, you're going to need to find 3 angles. Well, 3 parts. You're going to need 3 angles, and you're going to need 3 sides. For example, up here, we had 2 sides to start with, and the 90 degrees. Well, you have to have the 90 degrees. Now we're going to find out what is the missing side and what are the 2 missing angles. Well, we found one of those angles already. So that's how solving a right triangle works. You just got to break it down into the individual problems. When finding sides, we use trigonometric ratios. When finding angles, we use the inverse trig ratios. That's what we just got done doing. Remember to make sure your calculator is in degree mode. And we've talked about that. So let's talk about solving this right triangle. This right triangle tells us that side C is 20. Well, which side would be side C? Side C is always going to be across from angle C. So if they get tricky and put a C in a different corner, then side C is always across from angle C. Side A is always across from angle A, and side B is always across from angle B. Angle A is 54 degrees. So from that idea, we are missing, or we need to now calculate the measurement of angle B. We need to calculate AC, and we need to calculate BC. We need to find those three missing parts. You'll always be missing three if you're solving a right triangle. We have one of the angles, we have another angle, and we have one side. So those are three parts. We're going to find our third angle and the other two missing sides. So how are we going to figure out the missing angle?
Couldn't you just subtract like 180 from 54?
We know that a triangle adds up to 180. We also know that the acute angles of a right triangle are always going to be complementary. They have to add up to 90 themselves. 90 and then the extra 90 makes the 180. So acute angles of a right triangle are always complementary. So 90 minus 54 is going to be 36 degrees. So I like to write a 36 in that spot and then circle it because I calculated that value compared to ones that were given to us. Now we come and think about how to calculate for this side. Well, I'm going to use the 54 because that was the given information. Don't want to use a value that might be incorrect. So if I can solve it with information they give us, then I want to do that. 54. Next to the 54 is the adjacent side. Across from the 90 is the hypotenuse. Across from the 54 is the opposite side. So, for me to solve for a side, I need an angle. I've got one, 54. And I need at least one other side. I've got my hypotenuse. So, I'm going to solve for AC, adjacent, and use hypotenuse. Well, remember, thinking about SOHCAHTOA, if we're working with adjacent and hypotenuse, that's got to be the cosine, adjacent hypotenuse. This one is opposite hypotenuse. This is opposite adjacent. I definitely can't use that. I don't know either side value. Two unknowns. But adjacent hypotenuse, I can solve for this adjacent side. So we're going to use cosine of our angle, which is 54. Okay, from the 54 perspective, AC is considered the adjacent side. And of course, the 20 is considered the hypotenuse. Now to solve your ratio, you put it over 1 and cross multiply. Notice that the 1 is going to times your AC, so that's not going to change your AC at all. the 20 is going to times the cosine. So we need to put the 20 and the cosine of 54. Definitely don't multiply the 20 times 54. It's 20 times the cosine of 54. There's a big difference. So we can go to our calculator and say 20 times the cosine of 54, and we get 11.76. That gives me AC. Now I'm going to solve for BC. Well, BC is the opposite side. And we have the hypotenuse. So opposite hypotenuse is sine. So the sine of 54 equals opposite over hypotenuse divided by 1. And we cross multiply. Now, for both of these examples, we have not had BC in the denominator. When it's in the denominator, you're looking for the hypotenuse. You're going to multiply BC across. You would have to divide the tangent of 54 away. So that's a little tricky. But we don't have that in this case. Here, we're just multiplying. So it's 20 times the sine of 54. And we get 1618. And that completes us solving our right triangle. AC was 1176. We solved for that. And 1618, we circle it if we solve for that. Now you notice we know all three sides and we know all three angles. We completely solved the right triangle. So we come to our next problem. What do you notice that's different about this next problem?
There's no angles.
We're not given any angle value. We're given side A is 7. So remember, side A is across from angle A. Side B is across from angle B. So we're looking for side C, and we're looking for the two angles. Side C is the same way to name it is to call it AB. And we're looking for the measurement of angle A, and we're looking for the measurement of angle B. We already know the measurement of angle C. So notice us trying to solve for B. I can't use an acute angle and solve for the hypotenuse all at the same time. I don't know the angle, I don't know the side. I could calculate the angle, we'll need to do that. But I can solve for the side in a different method. Pythagorean theorem allows us to solve for the missing side if we know two sides already. And that's hypotenuse squared equals leg squared plus leg squared. So the hypotenuse squared, which is AB, and that's squared. One of the legs is 7, so we square it. One of the legs is 12, so we square it. So that gives us AB squared, 49 plus 144. That adds together to be 193. So AB squared equals 193. So we would need to take the square root of 193. Square root of 193 is the exact answer. That would be great for you to put down. But in terms of a decimal, That would be 1389. Remember, the longest side has to be the hypotenuse. So since we got 1389, that is the longer of all three sides. But it can't be any big number. It would have to be smaller than 19, smaller than the legs added together. That's the longest it could possibly get, is under 19.
Why didn't we use
So next we have to calculate the angle. You can solve for either angle you want. Let's solve for angle A. From angle A, the opposite side would be A, and the adjacent side would be side B. I'm going to use those two because those are my exact numbers that was given to me. If I use 13.89, that's a rounded number. Don't want to make any mistakes. So I'm going to use SOHCAHTOA. And we're solving for A, so that's going to be our theta, in other words. Opposite and adjacent is tangent. So tangent of our theta, or if you like, perhaps, if you prefer to call it A, because that's what we're solving for. We're solving for angle A. We can put an A there. And that's going to equal 7 over 12. We're going to switch those two, so it's tangent inverse of 7 over 12 equals a measurement of angle A. Notice before we did not talk about the measurement of angle theta. We just called it theta. But when we talk about capital letters, we have to call that angle A, and the correct notation is the measure of angle A. So second tangent of 7 divided by 12. That is 30.26 degrees. And then to solve for our last angle, you could just say that the measurement of A plus the measurement of B equals 90 degrees. You know that A is 30.26. You're looking for B, so we're going to subtract 30.26 from both sides. So 90 minus our previous answer gives us the 59.74. So if we use 90 minus 30.26, we're going to get that rounded value of 59.74. Either way you want to think about it. Measure of angle B is equaling 59.74 degrees. And we like to write that in our answer spot. So that is our trigonometry. Now there are story problems, and there's quite a few story problems here. We'll at least set them up. That's the tricky part, using the words to figure out what you're trying to set up. You're hiking towards the main road, so we're hiking this way. You reach a point where the road is flooded. So here the road is flooded. So to avoid the flooded area, you turn on a diagonal road that meets the original road at a 48-degree angle. We're going to go 3.6 miles on this diagonal road. How far were you from the main road? How much further could you have gone? Okay. If you had to come up to the main road and turn right anyway, it's probably an advantage to do this. But if you're trying to get back to this location, this will be longer than this side. We're going to calculate that value. So this is the adjacent. This is the hypotenuse. So we're looking at thinking about SOHCAHTOA. Which trig function are we going to use? So we're going to use cosine of our 48 because the adjacent side is what we're looking for and our hypotenuse is what we have. Then we could cross multiply and solve for that, just as we did before. Let's move on. A monster truck drives off a ramp in order to jump onto a row of cars. So here's a big ramp. Here's a bunch of cars. Just like my car. And then we have a monster truck that is driving up the ramp. Okay? Doesn't look too much monstrous compared to those, and you're going to jump up, maybe land on the cars and drive away. The ramp has a height of 10 feet. So we're 10 feet tall. If the truck drives 26 feet on the ramp, so here's the tricky part, understanding what information they're giving you. Where's the 26 go? The 26 is going to be the hypotenuse because the monster truck is driving on the jump for 26 feet. So it's got a pretty long ramp of 26 feet. What is the angle of the ramp? With the ground, what is our theta? This is called the angle of elevation. You're going to hear about that here in a moment. Angle of elevation. So, what two sides do we have? You can't do these without being able to label your triangles. So opposite over hypotenuse is sine. So we're going to do sine of theta to equal our opposite side over our hypotenuse. Then we're going to switch those two, so we have to use sine inverse to figure out theta. And you can easily calculate those out. We'll keep moving. Here's what I wanted to show you in terms of angle of depression and angle of elevation. If you look up at an object, you're on the ground, this is where you are. You're looking up at an object. Compared to the ground, compared to the horizontal, you have an angle of elevation. If you're up on top of a building and you look straight out, then you look down, that angle that's formed is the angle of depression. It's looking down. So if you look down at an object, the angle your sight line makes with the horizontal is called the angle of depression. Now, the mistake that a lot of people make is this angle is not inside of this triangle, and they often make it here. But that is not the angle of depression. Angle of depression is off the horizontal. Now, notice that the angle of depression and the angle of elevation make a Z shape. So they are alternate interior angles. So they're actually the same measurement. So that's another reason you cannot call this angle angle of depression. These two are the same. but they're in a different spot of the shape. So let's see what we can do. Always remember that angles of elevation and angles of depression are measured from the horizontal line. It's the angle of depression that's calculated incorrectly more often. Before attacking these problems, let's draw a picture to make sure that we can set the problem up correctly. And that's all we're going to focus on, is setting up the problem. From a point on the ground, 28 feet from the base of a flagpole, so we have a flagpole, the angle of elevation to the top of the flagpole is 63 degrees. To the nearest foot, estimate the height of the flagpole. From a point on the ground, 28 feet from the base of the flagpole, what is the height of the flagpole? So if you can measure that angle, and you know you're 28 feet away, then you can calculate the height of any item. So the opposite side, the adjacent side, so which trig function are we going to use? We're going to use tangent of 63. That equals the opposite side over the adjacent side. You'd put it over 1, you'd cross multiply, and say 28 times the tangent of 63. I'll let you worry about the calculation part of that. Let's see if we can get these next couple examples in. A parasailer is attached to a boat with a rope of 300 feet. So here is your boat. Speedboat there with a big engine hanging off the back. Right, just what you were thinking of. And then you have your parasailer out here, and you're hanging down. Okay, the water's going through here. So your rope is 300 feet long. The angle of depression, so from the horizontal, your angle of depression is 38 degrees. To the nearest foot, how high are you above the boat? So you have this measurement of how high are you up. You're 300 feet, but the angle they give you is 38. So you could either make your triangle come this way with the 300, and the height is going to be still the height, and the 38, or you can use alternate interior angles to say this is the 38. Either way you like to do it, the side opposite is the x, and the hypotenuse is the 300. Bless you. All right, 2 more. I'll let you calculate that on your own. If a building that is 52 feet tall casts a shadow that's 23 feet long, what is the angle of elevation? What is the angle looking up to the top of the building? Well, this is your opposite, this is your adjacent, so we're using tangent of theta to equal 52 divided by 23. And we'd have to use the inverse of 52 over 23. And then the last one for you to try, from a point on the ground, 64 feet from the base of a tree, the angle of elevation to the top of the tree is 28 degrees. To the nearest foot, estimate the height of the tree. So that would be the opposite, that would be the adjacent. So the tangent of 28 equals the opposite over the adjacent. And by putting it into a proportion, you're of course going to say 64 times the tangent of 28. We made it.